Good morning, students. Today we will discuss further study. As we study yesterday the concept of limit, today we'll study the continuity of the function. Uh, Continuity of function. As it is clear with the name continuity, meaning which is continue, which is not broken, which is not broken. We are talking about the graph of function. We are talking about the graph of function which is not broken. If it is continue along with its total path, it is continuous. When it is broken somewhere, it will be discontinuous at the point where it is broke. Okay, so we try to see this. What is the meaning of continuity? First, let me clear one thing. Suppose I am just telling you a simple example about f of x equal to mod x, and we want to know its graph, what it makes, how it makes. Look at it. I'm simple putting some values and try to find the values of y, corresponding value of y with respect to x. Suppose x we have a -2, -1, 0, 1 and 2. What will get? Definitely -2 if we put, it is 2. It is 1, it is 0, it is 1, it is 2, because all values are positive and same value. What about next? When these values we already have got, we'll go with simple graph. We have a 1, 2 and -1, -2. What about 0, 0? Here it is. What about 1, 1? It is here. What about 2, 2? It is here. What about -1 and -1? Or -1 and 1? And what about -2 and 2? Which is here. When you will join it, you will feel that it is your graph. Now, I was discussing with you continuity. So let me clear one thing. This is a continuous function. Why? Because it is not broken anywhere along its path. The second and very simple definition, while the function is called the continuous function, while making the graph of the function, we don't need to lift the pen. We don't need to lift the pen. Look at, I am making the graph, I do not need to lift the pen. So this function is continuous everywhere. What is the meaning of continuous everywhere? Meaning continuous at all x. What is meaning of continuous at all x? Meaning at all real number. Whatever we will put x is equal to, whatever we try to discuss the continuity of x at any point, we feel we will get that function is continuous. Like, suppose I say that, what about the continuity of function at x equal to 2? So look at where is x equal to 2. This x equal to 1, it is x equal to 2. Look at x equal to 2, it is not broken, it is continue. It is continue. What about x equal to 2.2? It is 2.2. When you will observe that the function is still continue at x equal to 2.2. So what about x equal to -2? Let's see, -2 here. When you will observe that x equal to -2, function is still continuing. So for a student it is very simple, that the meaning of continuous, very simple meaning as we actually use in our general life. Everything which is continue, like we are talking about the functions graph. When the graph is continue, the meaning is function is continuous. Function is continuous. And what about everywhere? Meaning all the real number when you will take at this point function, you will feel it is continuous. Lots of functions we might have here, like we take some more questions, more functions. Simple function I'm telling you. Suppose it is sin x. Sin x. How to draw the function of sin x? Let's see. I tell you. We should know that this is x, this is function. So we would have some negative values, some positive values, some like that. Suppose we have a -90. Suppose simple in degree I'm taking here. degree I'm taking here, it is degree, minus 90, suppose minus 45, minus 30, suppose it is 0, 30, minus 45, 60 I skip, no? 60 let me take here, 60, okay, minus 90, minus 60, minus 30, 0, 30, 60, 90, it is better. I dropped 45, no matter at all. Few values we need and we got. When we'll try to find the values, sine of minus 90 is, obviously sine minus 90 is minus sine 90, so it is minus 1. What about that? Sine minus 60 is, sine of minus 60 is minus sine 60. What is minus sine 60 is root 3 by 2. It is 1.73 upon 2. Approximately I'll get minus 0.8. What about 30? Sine minus 30 is minus sine 30. Minus sine theta is minus half, meaning minus 0.5. And similar to 0. And sine 30 is 0.5, 0.81. So I won't go very long. I would simply speak that the range of sine x is between minus 1 to 1. One should know minus 1 to 1. So I'll write only my 1 here, positive 1. It is a negative 1. So our definitely graph will hang between these two, will run between these two values. It will not go upside or downside. It will not break its limit. It will not go its beyond of these two limits. Okay, what about here? So I'll take some values like it is 0, it is a pi by 6, sorry, it is a pi by 3, it is pi by 2, say similarly it's a minus pi by 6, it's a minus pi by 3, and it's minus pi by 2. Actually the values are never end, but I have taken the few values I want to tell you about the graph of the function. Okay, let's look. 00 is pointing this point, 30 and 0.5 is 30 and 0.5 will look at this point, 60 and 0.8 look at this point, and this is 90, look at this point. What about downside here? We have a 30 minus 30 will give you minus 5, minus 60 will give you minus 8, and minus 90 will give you minus 1. So while making the graph, I will feel that this is a graph, this one. When you will exceed some angles, it will go like that. And when you will again go in the left directions, exceed some angle in negative direction, you would have a graph like that. So this particular graph is just like a heartbeat, and actually when you will see that it never ends. While making the graph of sine x, you will feel that it never ends. Excuse me. It never ends. So you feel that this time, what about the sine x? I would say that sine x is continuous function at all x, meaning at every number, this is your x, at every number whatever you will choose, the function at which function will not broken, function is continuous. So I would say function is continuous everywhere. These some specific sentences will help you in further work. You should remember that sine x is continuous everywhere. Similarly, if you will take cos x, definitely you should know the graph of the cos x. It is very simple again. I am not making you all. I have given the thing that how we can draw. When you will make the graph of cos x, it makes like that. Like that. So one should know that all functions, these functions are continuous. The meaning of continuity is the function should not break while in the path when we draw the graph. What about the tan x? Sometimes students feel that not getting the function which I discussed till now, mod x, sin x, cos x, all were continuous. But what about the discontinuity? So okay, let's begin that it is tan x. It is tan x. What about tan x? How to make the graph of tan x? Okay, I would simply speak something that when I'll make the graph of tan x, quick I would discuss that, because before starting the question we should know what is continuity and what is discontinuity. Because while making the question we know the so-called procedure we can use, we can get answer. But after finishing the answer, even those students know all the answer but don't know what is the real concept of continuity and discontinuity. So let's start here. About the tan x, we want to show that whether tan x is continuous at all the points as sin x and cos x and mod x, because sin x, cos x and mod x were continuous at all the real number x. What about the tan x? Okay, let's see. Tan x, we have a, suppose tan 0, we have a 0. I'm choosing only some values like 30, 45. It's a good value here to take. Even 60 and 90 I'm taking. Okay, fine. It is a minus 30, minus 45, minus 60 and minus 90. Okay, these values are good enough, x and y. What about tan 30 is 1 by under root 3, 1 by under root 3. What is its approximate value? Let me rationalize that. Under root 3 upon 3, under root 3 meaning 1.7 upon 3. So it is approximately 3 5s are 15. Approximately it's a 0.5. Okay. What about now? It is a 1045 is itself a 1. You should remember. 1060 is a root 3 meaning 1.7. It's good enough. It's good enough. And what about 1090? It's infinity. It is infinity. Sorry, 1060 is 1 by 1.7. Yes. Now I don't have to do the hard work because I know it's all negative values like that. Like that. Now I'll go. Okay, we have a graph like here, x dash y dash, and now look at the thing. This is suppose 1, this is 2, and this showing infinity. This is minus 1, this is minus 2, this is gonna minus infinity, and this is suppose angle shows here 0. This is gonna be 30, 60. 60 and 45 we have yet to go with now. Okay, no matter at all. This is suppose it is 30. This is 45. Suppose it is 60 and it is 90. And similarly it is a minus 30, 45 suppose. 60 suppose and minus 90, and between these two a graph will formed. Look at, between these two a graph will formed. Now quick go on. 00 is being here, 30 degree means this is 0.5, 45 is itself for 1, 60 is itself for 1.7. Look at 1.7. This is, and for 90 it is infinity. So for 90 particular it is infinity, and one should know that infinite is itself an imaginary value. I would say that actually 90 cannot happen. Just near to 90 it is near to infinity. So it's near to 90, it's infinity. Near to infinity. Look at the point I plotted. I cannot touch this because 90 at 90 it is completely infinity, which is actually not x's value. So I would say that instead of x I cannot take value x equal to 90. Look at my words. Hear my words. I cannot take x equal to 90 because 1090 is itself infinity and it is not x's value. So I cannot take x equal to pi by 2, so I can't take infinite value. So I have chosen some near for some near value of 90, it is some near to the infinite. And what about the similar left hand side, in the left portion, minus 30 is a minus 0.5, minus 45 is a minus 1, minus 60 is a minus 1.7, and similarly for 90 it is near to the minus infinite. So when you join all this graph, you will have a good graph. Observe these two things. I did not match these two because this graph cannot touch this line. At this line x equal to 90 and value is infinite, which is not possible. So I have maintained some gap here, also some gap here, and when I will continue this graph, I have to extend some values in degree, this section or this section. I would have more graphs. This is a standard actually range, and after this you might have a lots of this kind of range, this kind of graphs. When I will make the graph for the next further values, I would have a similar graph like that. or here like that, and this kind of a graph will be continuing from both the side. This is a principal branch, so that I have taken here. But you have to concern that while making the graph, where you lift the pen. This was the particular graph. I am not lifting the pen anywhere, but at minus 90, I have to lift the pen. When I was making the graph, I have to lift the pen at 90. So what we have feel here, that at 90, at minus 90, function is not continuous, because at these 2 points I have to lift the pen. Similarly, more here, these were the minus 90 to 90. It is 3 pi by 2. Definitely will be 3 pi by 2 and minus 3 pi by 2. What about now? These point, at this point also we have to lift the pen at 90 and 3 pi by 2, and this also. So at all these particular points, this particular tan x is not continuous, because at this particular point we have to lift the pen while making the graph. So student, hope you have till now got what is the meaning of continuity and discontinuity. If I ask you whether this function is continuous at x equal to pi by 4, let's see, pi by 4 is here. So this particular, at point, this particular function is not broken, it is continuous. What about x equal to pi by 6? The function at pi by 6 is not broken, it is continuous. So meaning of that, function is continuous in its domain. Meaning, where the function it not exist, at all those points where the function it not exist, at all those points function it not exist, meaning function is discontinuous at that point. You should have a good knowledge about that. I would speak that function is not defined at x where belongs to 2n plus 1 pi by 2. Sorry, these are the points where function is not continuous. Still confusion? Let me speak. Put n equal to 1. 2 1s are 2 and 1 3 pi by 2. I told that 3 pi by 2 function is not continuous. Put n equal to 0. It is 0 plus 1 pi by 2. At pi by 2 function is not continuous. Put n equal to minus 1. So minus 2 plus 1 minus pi by 2. This minus pi by 2 is a point where the function is not continuous. So I would say that function is continuous except this, meaning r minus this. And this is none else, it is a domain of 10x. It's a very deep thing, but you should have a knowledge about that. Okay, so I don't want to stretch now this concept because it will be so long. But I had to tell you only the concept of the continuity, which I hopefully succeed to tell you. This is, now let me continue the portion continuity of the function. I was talking to you about, if I ask you that show that function 2x plus 1 is continuous at x equal to 3. So very initially what will come in your mind? That I have taught you that first you will draw the graph and you will check that x equal to the function, whether the graph of function is broken or not. Like you will quick go with x and y, you will choose some value like 0, 1, 2, 3, you will find some value like 2, 3, 5 and 7 and will make the graph, and let's see that it is a 0 and 1, 1 and 3, 2 and 5, 3 and 7, and it's the graph. So you will check that x equal to 3 is a 1, 2, 3, oh at a 3 it is not broken. Function is continuous. But what is the process quickly I have done? This is actually rubbish, because all the time you cannot make the graph. In case of this, if I suppose to have 2x cube plus 1, and then I will ask you that, look at, instead of a 2x plus 1, if I would write 2x cube plus 1, and if I'll ask you that does function continuous at x equal to 3? So will you use a similar method of while drawing the graph, you will check it? Because this time graph is not so easy for one and all. 2x cube plus 1, the graph is complicated. Even 2x to the power 4 if I write, the graph is still complicated. For simple function, for understanding the concept of the continuity, you can learn with the graph, but all the time you can't make the graph. So okay, but question, you have to solve this. So you should know the procedure. So let me check it out. Okay, let me rub it, and I am writing instead of that. y is equal to f of x, whatever the function, write it f of x, and I am checking the continuity at x equal to a. A is any point, in radian or degree or any simple real number. Now we have to check y is equal to function is continuous at x equal to 0, x equal to a. So what to do? What is the shortcut? What is the fundamental method to check without drawing the graph? What can we do? So let me speak something that what can we do. Any function y is equal to f of x will be continuous at x equal to a. Look at function may be anything, any function can come, point can come any point. Okay, so function, if any function y equal to f of x will be continuous at x equal to a, so we have to check something. So this is the checking I am telling you, I am sharing with you the checking. You have to go first, right hand limit at that point should equal to left hand limit at that point, and this both should equal to the value of function at x equal to a. If these three will be equal, I would say that function will be continuous at x equal to a. If even a single part will not satisfying, function will be discontinuous. So I will make you write after this the properties, or sorry, the ways when the function will be discontinuous. But first of all, guys, you should remember, you just have to go the right hand limit. Yesterday I explained very well. Right hand limit, I have told you the shortcut, and f of a is very simple, the value of function at x equal to a. You just have to put x equal to a in the function, you will get f of a. So all three should same. If these all three will be same, function will be discontinuous. In the next aspect, I would say function will be discontinuous. Okay, so now you are thinking that when function will be discontinuous, it is a three-way. First, if either right hand limit or left hand limit both comes not exist. So student, you don't afraid about when you will find the right hand limit or left hand limit. Sometimes student get infinite answer. So while using the right hand limit or left hand limit, if your answer is not exist, meaning function is discontinuous. Look at it is not hard. Even while reading the thing, you will feel tough, but it is not so hard. Listen me carefully. When you will find right hand limit or left hand limit, when your answer it not exist, meaning infinite, then you will say that function is discontinuous. Okay. If both limit exist, meaning if this is exist answer except infinite coming, this is exist answer except infinite coming, and limits extends to a and right hand limit, unfortunately both are not equal, meaning right hand limit and left hand limit, even they are exist but they are not equal, function is discontinuous. And third, I think you have caught that if both limit extends to a plus and extends to a minus function are equal, but unfortunately it is not equal to f of a, function is still discontinuous. Meaning this time the bounded field is what? All three values should same. Even a single, if the property will not satisfy, function will be discontinuous. So hope student this will help you, but you should write all the term, this points in a fair copy and do practice. Okay, let me tell you one question, that how we can show the continuity of any function. Look at, suppose I am taking here the question, example number 10, and with this I think I could tell you the way of writing the function. Okay, look at, discuss the continuity of the function x plus 2, x minus 2. This is the question, and actually it is very good question. While studying the continuity, it is important one. First, I would speak one thing. Its question is for learning, it's a lot of there is in question, so look at properly. First of all, I would ask you one thing, that here the written discuss the continuity, and the question is absent with at what x equal to, at which point it is discussing. Look at students, very important thing I'm telling you, that discuss the continuity at some point should be here, but it is not written, it is not mentioned here. So it means that you have to discuss the continuity at all x. So what is the meaning of all x? Look at, I tell you, it is 1. It is infinite. It is minus infinite. It means you have to discuss the continuity function at all the x. Look in here. 1, more than 1 and less than 1. That's a very good thing. Because it is not specially mentioned here. If it is supposed to be x equal to 1. Now look, discuss the continuity at x equal to 1. So we don't have to run away here or there. We only focus at 1. And you know the method. The right hand limit and left hand limit and main value should equal. So this time guys, the question is discuss the continuity, only this question. So we will take all the values. So how we can take all the values? First we will choose the value which is greater than 1. Second we choose the value which is less than 1. And then third we'll take exactly 1. I think you're getting me. Okay. It is 1. I will take some value which is actually greater than 1. Suppose it is a, which is x equal to a greater than 1. And I'll prove the continuity at a. So, okay, no worry about it. Look at with me. I will tell you each and everything. First condition, let x equal to a which is greater than 1. Hope this may be tough for you. But if you will think the statement of the question, you will know that what I am doing. If it is written, if at x equal to 1, student, you just have to find the right hand limit at 1, left hand limit at 1 and main value at 1. And all three when equal, function is continuous. But if it is not written guys, you have to find the continuity at all x. So what are the all x? It is 1. Less than 1, infinite point, right hand, greater than 1, infinite point. So I have to choose any value like a which is greater than 1. So that x equal to a which is greater than 1 I've taken here. So look at, I tell you, first I'll take right hand limit at x equal to a which is greater than 1. Look at, this is 1, this is a. Right hand limit I'm taking, x tends to a plus function. Now big question is, what is the value of function? This or this? Because function is either this or this. So at the place of function I have to write something. So look, I tell you, x tends to a plus. What is the meaning of that? It is something 2 or something 3 like that. X tends to a plus meaning x is coming to a from right direction. X is coming to a from right direction, which is here. X is coming to a from the right direction, and in that sense it is maintaining the gap h. I told you yesterday, in whole scenario if you'll see that x is greater than 1. Look at properly. These two functions depending on 1. For x less than 1 it is. For x greater than 1 it is. For x equal to 1 it is. But it is not 1 now. It is x equal to a which is greater than 1. Any value which is greater than 1. So look at it is a. I am finding the continuity at a which is already greater than 1 because I have taken here x equal to a which is greater than 1. So this a is actually representing all the values greater than 1, and together with it is infinite. Suppose it is infinite, I am finding actually the continuity at all a which is greater than 1. So I have taken a. For right hand limit, x tends to a plus meaning x is coming to a from the right direction. In that sense, you can see that x is greater than 1. So x is greater than 1 where it is appearing, x is greater than 1 which is x minus 2. So it is decided that for this particular it is coming x minus 2, and shortcut I told you yesterday. What shortcut is it? Is you should write h tends to 0. Instead of x you will write a plus h minus 2, put h equal to 0, it is a minus 2, it is a right hand limit. When I go with the left hand limit, it is a right hand limit. When I go to the left hand limit x tends to a minus function. What is the meaning of that? Still a is placed same, and x is coming from the left direction to the maintaining a small gap. So this time even when you will search out f of x, sometimes students write this one because first time they have written this one. So no, it's not thing. Look at x, which is actually reaching to a from the left direction, still the position of x, which is again greater than 1. Again greater than 1. So again greater than 1 meaning x minus 2, you have to write the same thing guys. It is x minus 2. So I don't have to waste the time. Both same. It is limit h tends to 0 will come here. Instead of x you will write a minus h minus 2 and answer is a minus 2. Both are same. What it meaning? And lastly I would speak something LHL, RHL and main value. What is the meaning of main value? At x equal to a, all three should come. What is x equal to a? Function will be chosen what? This or this. So at x equal to a is again greater than 1, meaning again you have to choose the same value, x minus 2, f of a will be chosen, a minus 2. All three are same, meaning function is continuous at all x greater than 1. Meaning all greater than 1 value function is continuous. So similarly you can please do by your own. Similarly function will be continuous at all x equal to a which is less than 1. Whatever value, if I choose x less than 1, I have to go similar thing which is here and the function will be chosen for all this and value will be same. So do by your own this. And last question is still remaining, that what about continuity at x equal to 1? Now we discuss. This time I found the continuity all for the value which is greater than 1. Similarly sentence I have written for all the value which is less than 1, but 1 is still remaining. So now we discuss the continuity at x equal to 1. So right hand limit I'll choose quick, x tends to 1 plus function. Now look at the thing, x tends to 1 plus meaning this is 1, x is coming to 1 from the right side. Look at this time x greater than 1. So x greater than 1 is here, x minus 2 will come. So change it by h tends to 0. It is 1 plus h minus 2. Put h equal to 0, it is minus 1. When I go with the left hand limit x tends to 1 minus function, meaning this time x is coming from the left direction. So this is x less than 1, meaning x less than 1 is x plus 2. So I'll go with x tends to 1 minus x plus 2. I'll go with limit h tends to 0, 1 minus h plus 2. This is 3. And unfortunately, left hand limit and right hand limit are not equal, meaning function is discontinuous at x equal to 1. What I will write? Left hand limit not equal to right hand limit, meaning function is discontinuous at x equal to 1. This is the answer, meaning function is continuous for all x which is greater than 1. Function is continuous for all